All right. Well, welcome everyone. I'm JJ. Normally we'd be just jumping straight into an example. We're going to talk through moments a little bit today, and before we even do example videos for that, one of the key things we have to be able to do is figure out, will a force cause a counterclockwise or a clockwise rotation about whatever point we're summing moments up about. Everyone tends to struggle with this when we are starting out with statics. It's not an uncommon thing that this is just hard for everyone. I have a trick that I use, but it just doesn't work well to show that on this type of a setup. So we're going to introduce it here, kind of what we're doing now, and then we're going to switch to just a document camera. But let's go ahead and talk through that. So we'll switch over.
All right, so we're going to jump in and tackle our example. We're trying to determine the moment the forces would cause about points A, B, and C. And really our intent in this example problem is to try to come in and illustrate, how do we figure out, will these forces about any point that we take a look at here, are they going to cause a counterclockwise or a clockwise rotation? We got to get that rotation direction right as we're dealing with moments, or everything is going to go wrong in our moment. We're kind of just guessing blindly then. We don't want to do that. So let's go ahead and try this. We're going to introduce what I call either the spinning method, which is not at all a technical term, or also not a technical term, the pin it and spin it approach to tackling moments. So let's just jump in. We're kind of going to illustrate that as we go through our problem. So our first point, we're taking a look at our moments about point A. So I could come in and say, with positive going counterclockwise, I am summing up my moments about point A. And if I'm doing that, I can set this equal to, and I have two forces I need to check in here. So rather than just saying, oh, this acts in the positive direction, that one acts in the negative, I need to say, what rotation will they cause about A? Our 75 is going up, 125 to the left. So I'm going to loosely, just gently hold my paper here at point A, pin it down to A, and let's check that Y component first in here. It is pointing upwards, so I'm going to line my other hand up with the force and just push in the direction. If our force is at an angle, we break it up into components every single time in here. We already have the components here. So I'll line it up and push just straight up on my paper. As I do that, if I actually let it spin, my paper is going to start to rotate counterclockwise in here. So that's 75-pound force, because when I pinned it and spinned it, it rotated counterclockwise. I should put its moment in here as positive. It doesn't matter that this was pointing upwards, or we're not basing it on this point in the positive Y direction. It's entirely on, does that force cause a clockwise, counterclockwise, or a clockwise rotation for us? Counterclockwise is what we just said. It's positive, so we need our force, 75, times distance from the line of action of our force, from my finger here to point A. That shortest possible distance is always going to be, for a Y force, an X distance, 14 feet. So 75 times 14. And then we're going to check that exact same thing for the X component. So still pinning this to A, I now line my hand up to the left so I can push to the left on this. If I do that, my paper starts to rotate counterclockwise in here. So even though this is a negative force, it points in the negative X direction, it is causing a counterclockwise rotation. I assumed counterclockwise was positive, so I'll add this in. Plus my force, 125, that's an X force, so I need the Y distance from my pencil down to A, the line of action of our 125-pound force, down to A. My Y distance is 10 feet here. So times 10. And that's it for us. Summing this all up, I'm going to get that my total moment about point A was equal to 2,300 pound-feet. And we get a positive number out from this equation. I assume positive means it's counterclockwise, so I'll add that in at the end, getting our positive answer with the correct rotation direction. Let's take a look at point B. We're going to get one of these two is going to be negative then. So what do we do then? So let's come in and we'll say again, with positive being counterclockwise, let's sum up our moments about point B. So now I'm just going to pin my paper at B rather than at A, and repeat that exact same process. If I pin at B and push up on the Y component here, I rotate counterclockwise. So I'll put it in as positive. 75 times my distance is still from my pencil to B, 14 feet. Times 14. But when we come and check that x component, if I push to the left here, just right here, pinning at B in the top left corner, my paper rotates clockwise. I took counterclockwise as positive, so that just means this is a negative moment. So minus my force, 125, times my distance, again from the line of action of that force, from my pencil to B, that shortest distance is always perpendicular, 6 feet. So times 6. And this is going to get me a smaller number because I'm subtracting off a moment here. But my total moment about point B should end up being 300 pound-feet. I'm still getting a positive answer out from this equation, which means I still have this going counterclockwise. And then finally we can come in and say, let's check point C at the top right up here. So if I come in, we'll start our equation here. With positive going counterclockwise, I'm summing my moments up about point C. So again, we can check our x and our y components. If I look at that y component, the line of action passes straight through point C. So my distance from the line of action from my pencil to point C, well, point C is on that line of action. That distance is 0. So 75 times my distance of 0 gets me 0. This 75-pound force won't cause any moment about point C. So we're just going to leave it off of our equation. There's no need for us to even include it in here. 75 times 0, just skip it. Anytime our force's line of action passes through a point, we should be able to say it's going to cause no moment about that point. Here, that's the y component passes through point C, so we don't need to include the y component in here. But we will check the x component, 125. It goes under C, so I do have to include it. It's going to the left on this, so if I pin now at point C and I push to the left, I am rotating clockwise on this. We just said that positive was counterclockwise, so my equation, I'm going to put this in as a negative moment. Negative force, 125, times distance, 6 feet. Is going to get me that my total moment about point C is negative 750 pound-feet going counterclockwise. Remember, for moments, we always want to report our answer as a positive, not a negative here, and then get the correct rotation. So a negative counterclockwise is really a positive going clockwise. So we'll change that one last time. Our moment about C is 750 pound-feet going clockwise for everything. Notice as we tackle that, we could assume any direction at the beginning of our equation is positive. I pretty much exclusively do counterclockwise because it's the same and that makes it easier for me to deal with. But if we had assumed clockwise at any point, we would get the same answer. For here, for example, at C, if I said positive was clockwise, this would have been a positive 125 times 6. We have immediately gotten it as 750 positive pound-feet clockwise. Our answer will work out the same no matter how we set up and make our assumption at the beginning of this equation. If we want to document what are we assuming, it makes it so much easier to follow our work.
All right, again, hopefully that's a useful thing for us. We can come in, we can figure out rotation directions. There are other ways that we can do that. I'll show another one in a moment example problem. So watch more videos and you can get that one. That's the one I tend to use though. That's the one that my students tend to say, that's by far the easiest thing for me to go in and do. It gets us there, it works well, it's easy. And a lot of engineers are super hands-on, or they want to be, and it makes it a real quick and easy hands-on thing that we can try. So hopefully that's useful for you. If it is, hit that like and subscribe button. Let's get Q&A with JJ.